First, I was the chair of the scientific program committee in charge of the selection of plenary and review speakers. So I thought I should review some of what we have done. So we have this string planning committee that chaired by David Gross, and our friend in China reached out to us and then suggested to have strings conference. And then it was officially announced on July by David Gross. And then in September, we are asked to be on the scientific program committee. So this is a member of the committee. And the committee charge was to determine the format of scientific portion of the conference and select plenary and review speakers. And then the local organizer was very gracious to include the sentence that the committee should have autonomy. And so we had freedom to choose speakers based solely on scientific merit. And we are very grateful that local organizer actually honored this commitment. And then I believe that you have seen the consequence of this wonderful list of speakers. And so I thought we should discuss a little bit about the demographic of plenary and review speakers. And of course, demographic is something dangerous to talk about. And, but the compliance officer of my university tell me that the PhD year is not protected characteristic, so we can talk about it. So here is the academic age of plenary and review speakers according to the, so these are black, the red are postdoc, purple junior faculty and senior faculty. You see that the majority of speakers are actually within the first 20 years, from PhD, starting from postdoc, going to junior faculty, and more senior faculty member. But then if you look at this, there is of course this distinguished group of people who have made foundational contribution to string theory and continue to be leading the field. But if you look at this, there is actually, after this, there is more than 10 years of the gap until you get to Juan Maldacena and Marcos Marinho. And then I was wondering, by looking at it, who are people in this lost generation? And I realized that I'm actually right in the middle of this. And there is another observation I can make, which is that discoveries and breakthrough characterize generations. So, and of course, there is a superstring revolution here, and then second superstring revolution, also known as string duality revolution, and then ADS-CFT correspondence. But these are not only discoveries and breakthroughs that shape the generation. There are many, many ideas, beautiful ideas, and powerful tools developed. For example, this year is the 50th anniversary of Yao's proof of Calabi conjecture, which we'll be celebrating in September in BIMSA. And these discoveries were indeed important ground for the superstring revolution. And so these discoveries are not made in isolation. For example, we see a lot of talk about related to review theory or matrix model, and these happened over here. And then there is continue to be beautiful parade of ideas and powerful techniques continuing. So there are lots more to look forward to. We can also talk about the geographic distribution of plenary and review speakers. So here, red dots are Asia, purple are Europe and Canada, and blue is USA. And you see that there are a little bit more US speakers, but in the younger generation, there are many from Asia. But if you look at PhD institutions, it's actually majority of them are USA, which means that many of the speakers got PhD in the US, but then in Europe and Canada also. But since this, if you look at this, there are lots of people, young people, active people in Asia. So that would mean that in the next 10 years or so, there will be more speakers from Asia, one could expect. Just for comparison, here is a demographic of the committee member, which is evenly in Asia and USA and Europe, as you can see. So this is how sort of we selected the speakers. So with that, I thought I had done my job and would enjoy Strings Conference as a participant, but it didn't work out that way. that Slava Risov wrote to me about a couple of weeks ago, saying that some of the local organizers liked your review talk at Strings 2024, and he wanted me to do the same thing. So first I had to remember what I did 2 years ago. And at that time, actually, Andy Strominger and I led the discussion in the closing session. And we actually collected questions from the string theory community. But we thought that the big questions like unifying quantum theory and gravity may not be sort of not so easy to discuss. So we asked questions that can plausibly be answered within the next 10 years. And then we collected 100 questions, and these are still available at the Strings 2024 website. And then we use that to discuss some of the development of string theory at that time. So I thought, well, following up on that and honoring the request by Slava, what can I do? And then I remember that, well, now I'm sort of also the division chair of the physics, mathematics, and astronomy. So I remember that I realized that in university, actually, if you have a tenure track faculty member, we have a committee that monitors the progress towards the tenure. So I thought, well, maybe you can try something similar, which is to ask those who had submitted questions before, 100 questions, and other colleagues, and ask them to provide their candid assessment of our progress over the last 2 years. Namely, that are we on track to solve these questions within the next 8, namely 10 minus 2 years? And should we keep some of the questions or revise them or perhaps retire them? Namely, is string theory on track to earn tenure? So we got 59 responses. Some suggested they want to keep the original question, some revised and updated after 2 years. And these questions are available at this Strings conference website. So I organized these questions into various different categories. The largest group of questions were about Worldsheet, which is very interesting. So Worldsheet description continued to be actually important ingredient in string theory. So the Ova Faroni actually sent me the first questions and a response, and he actually wanted to keep the original question, which was, what is the classical string theory dual to large n limit of 3 plus 1 dimensional QCD? And he said that I'm still hoping that it can be answered in 8 years. We are close to answering the analogous question for 2D QCD, but of course, that is a much easier case. And Igor said that perhaps in n equal 1 case is tractable and suggested a way to find string dual. And then there are also Viktor Gorbenko and Leonardo Rastelli provided similar questions. There are several people who have asked questions about Worldsheet formulation of string theory in ADS, and so both from the point of view of ADS Virasoro-Shapiro model description and generalization, but also top-down, sort of, or bottom-up, should I say, description in terms of ADS3 background with Ramon flux. Matthias Gabadier says that they are beginning to get ADS3 background with Ramon flux under control. And Rajesh Gopakuma asked, can we use conformal bootstrap constraint to gain insight into string Worldsheet in ADS? And in fact, there was a talk by Shai Chester related to this question. There are also outstanding questions about how to describe Worldsheet for non-stationary background. This was asked by Nikita Nekrasov. And he pointed out some interesting paper by Chianti, Eberhardt, and Misera. So actually, I'm planning to study some of those papers. Space of theories is another interesting topic that has been lots of discussion on this subject at this conference. So one possible way to approach it is to look at the situation with large number of supersymmetry. So Mike Douglas suggested he wanted to keep the original question, which is, is there a simple description of the complete set of all string M-theory compactification with 8 supercharges? And Leonardo Rastelli wanted to use a bootstrap to classify space of consistent superconformal theory. And he pointed out that for maximally supersymmetric theory in D equal 4 or 6 dimension, embedding string theory and M theory suggests that we already possess complete list. And asked, why can't we put it on a rigorous footing by purely field theoretical argument? And I think there is actually a path toward doing something like that. For example, let's take N equal 4 superconformal field theory in 4 dimension. Of course, N equal 4 super Yang-Mills is an example, but is this the only example? So one way to think about that is that, well, it has a unique stress tensor multiplet. So the conformal manifold is one-dimensional and it is locally hyperbolic. So the question is that, is there infinite distance limit in this conformal manifold? What happens if you go to infinite distance in that direction? If it becomes free theory, then you can see that, you can only have N equal 4 super Yang-Mills. So this is like one way to approach this question. And this is actually closely related to the distance conjecture. So distance conjecture is now celebrating 20th anniversary this year. And this is what Kumran and I formulated, starting with the conjecture that every parameter in quantum gravity is the expectation value of some dynamical field, and that moduli space has infinite diameter, and if you go to infinite distance, there is actually an infinite of light particles starting with a mass of order exponentially suppressed, e to the minus alpha phi. So Timo Weigand gave a beautiful summary of current progress in understanding this conjecture. And so, in fact, the CFT version, ADS CFT version of this conjecture has had lots of progress in the past couple of years, and we have gained quite a bit of insight in the CFT version of distance conjecture. So there are lots of things that we can still do in this direction. I think one of the surprise at this conference was talk by Jake McNamara, who actually presented a claim that unitary quantum field theories are determined by the closed manifold partition functions, and every reflection positive partition function arises from a unitary quantum field theory. So in some sense, this function, which is the partition function, can be used in this kind of classification program too. Although this work was originally motivated by some of the holographic questions that raised by Jianbin Yang, raised in the review talk by Jianbin Yang. But this can be stated as a purely quantum field theory statement, and can be relevant also to this question of understanding space of quantum field theory. So symmetry is also another element that is very interesting to look at. So in this context, one interesting direction to think about is that quantum gravity is supposed to not to have global symmetry, but then the question is that can we quantify how symmetry can be broken, for example? So those are that's a question that asked by a couple of people. Miguel Montero amended his question that he submitted 2 years ago, and now he says that can we precisely quantify or prove bound on the amount of breaking of global symmetry in quantum gravity? And then Julio Paramartinez asked a similar question, but in this formulation, that is there a lower bound on the on the cross section implied by no global symmetry in quantum gravity? So holography continued to be inspiration for many progress in string theory. And Juan asked 2 years ago that could we understand better any holographic example relating matrix integral to Euclidean gravity solutions that are described by Einstein gravity. So KKLT was in fact proposed many years ago as an example of this. And then, in fact, after Juan asked this question 2 years ago, immediately after that, there have been a couple of very interesting progress in this direction. identifying the holographic pair by deforming the original version of KKLT matrix model. So there can be interesting progress in this direction too. And Andy Strominger asked, is LW1 plus infinity a symmetry of string compactification to 4D flat space? And he himself actually provided some evidence that there is a progress in this direction by considering the ADS-CFT version of this question. Uniqueness of string theory is another interesting question. So, this is an area where there have been some very interesting progress, and Cliff Chun reviewed this progress. So Grant Lehman revised his original question. 2 years ago, he asked whether you can actually, the string amplitude can be unique under certain condition. But since then, more recently, he did this work with Cliff and the collaborator. So he amended the question by saying now that we have found a set of S-matrix bootstrap conditions that uniquely output the mass and spin spectra, as well as the amplitude, can we physically motivate these requirements or weaken them? In fact, this work is interesting in the sense that it sharply defines under what assumptions string theory can arise. So you can ask whether these assumptions are reasonable or whether we can weaken the assumption, etc. So this can be a starting point for the question of uniqueness. So finally, there is also a question of definition. So Daniel Harlow sent me this question that quite a lot, perhaps most of the progress of quantum gravity in the last 20 years has happened using methods that, although partly motivated by string theory, do not rely on the detailed UV structure of the theory. On the other hand, progress toward finding a general non-perturbative formulation of string theory has largely stalled. Now, I disagree with this claim. However, since he's not here, I do not feel I should make rebuttal in his absence here. So instead, I would like to suggest a couple of areas where progress has been made. And one is the string field theory. So Monkey Kim asked, well, can be formulated non-perturbatively? And can we learn something about non-perturbative physics from string field theory? In fact, string field theory was reviewed by Ashok and discussed by a couple of speakers. And then in the discussion session on definition of amplitude, there were a lot of discussion about string field theory. So it's clear that string field theory is very useful in organizing and calculating ambiguously perturbative amplitude. There has been some use of string field theory in getting glimpse of non-perturbative physics, such as open string tachyon condensation by Ashok Sen. But I think that now that string field theory has been established as actually a complete description of perturbative string amplitude, perhaps we can push this further and try to gain some non-perturbative information from here. Another way to gain non-perturbative definition can be resurgence, and there have been several questions in this direction, and this was discussed by Marcos Marino today. But this description might not give a complete definition of string theory, as pointed out by Slava Rychkov, and he asked, can we actually axiomatize a notion of string theory? Well enough so that a statement like there is a dual string theory description of gauge theory, or there is a dual string theory description of critical 3D Ising model become sharp questions allowing, at least in principle, yes or no answers. So with his questions, I just pointed out where the questions have been organized into these 6 areas, and each has had lots of interesting ideas and many sources of further progress, and there are lots of things to look forward to. But in fact, I still have one more wish to solve, which is a question about machine moonshine, because this was actually the calculation I did in my PhD thesis many, many years ago. And only after 21 years, we figured out that these expansion coefficients are related to Massieu group. But the origin of this is still not well understood. At least Greg Moore thinks it's an interesting question. And then Ifan just suggested maybe there is a way to address these questions. So I think that this is actually still very interesting questions. Maybe perhaps after 20 years, maybe 2030, by 2031, we may be able to finally understand where these symmetry come from. So maybe we can say that string theory has not earned tenure yet in the sense that it has not been experimentally confirmed, but it's very promising. And if I were the department chair deciding this reappointment of string theory, I would be very pleased to reappoint string theory as a candidate for fundamental laws of nature, that we are very impressed by what string theory has accomplished, confident in its trajectory, and excited about its potential to identify the fundamental laws of nature. So scientists are like travelers without maps. String conference provides us an oasis to pause, compare paths, and see how far we have come. As Shin Chiji of Southern Song Dynasty wrote in his poem, Chen Shi Ju Buju, Bijin Don Liu Chu. Great mountains, green mountains cannot stop the river. In the end, it flows eastward, which means toward the sea. May the idea and techniques discussed at Strings 2026 continue to flow, and may we have great fun discovering where they lead. So I could have stopped my concluding remark with these uplifting comments, but I feel that I need to address the elephant in the room. So I'm going to say something, and if you feel compelled to boo me, you can do that, but please keep it brief so that I can continue my remarks. So I'd like to discuss impact of AI on string theory. No? Okay. So in the case of AI had lots of impact already in the research in string theory, but I don't think anyone can confidently predict what capabilities that AI will acquire over the next few years. So we cannot even ask similar questions in the 10-year time scale. So instead, I asked the same group of people, which aspect of AI and the future practice of string theory should our community be considering now? And what would you say to graduate students beginning string theory today about the possible role of AI in their scientific life? So we got a lot of interesting responses. Some group of people say that, in fact, it gives a very large verified knowledge basis. It's curated and reliable, and it can help to identify unexpected connections. Julio Para-Martinez said that, in fact, the bottleneck of many programs in our field is not intelligence, after all, but attention. So he expressed a hope that AI will cure this bottleneck by solving all the problems solvable with the current tools and leaving the interesting hard one for us to explore. It also helps us, in that vein, it helps us ask new kind of questions, namely that change what kind of program we would even find tractable. And Julio also says that if agentic LLM loop can solve your problem, perhaps you need to find a better program. So I think, as Andy says, that I'm cautiously optimistic that we learn a lot from using this tool. Of course, we have to be very careful in using it. Verification should always come before belief, as Shurdeep correctly said. And Ricardo Schiappa says that perhaps we should consider writing less paper, but better paper, and much harder paper. So that's an interesting suggestion. Creativity is something people are unsure whether AI can acquire. So Nikita says that perhaps for graduate students, foundation creativity and authenticity is even more precious. And we should develop more of the ability to come up with ideas. But we don't know. AI might acquire such capability in the next few years. And Greg asked, will a human HEP-TH physicist working with an AI agent finds that agent and not the human has formulated a truly new and beautiful idea. In fact, some of what I consider to be most creative member of our community said that openly consider the possibility that AI would overtake us in this area. So, for example, Ashok Sen said that if eventually it overtakes us and solve the problem of quantum gravity and all other forces, I'll be happy. And Yuji Tachikawa says that I don't think the reasoning capability has an upper bound given by the genetics of Homo sapiens. So therefore, I won't be surprised if AI might become vastly superior to human in the ability to do theoretical part of research, and she seems to be okay with it. So you see, lots of people have different view on how this is going to go from now. But among many of these ideas, the one that I like most was from Juan Maldacena, who said that I would tell graduate students to ignore what I and others in my generation say about AI. I would encourage them to learn to use it in novel ways to solve physics problems. I think that's a very good suggestion to us, I think. So those are all very interesting suggestions, and of course the question would be what AI would think about such responses, and of course I asked that to ChatGPT, and here is the response. I asked, what do you think of these responses, and says, they are reassuring. I especially enjoy the recurring hope that AI will remain a tool. Future historians may find that adorable. I didn't make it up. I could have made it up. So this is what the ChatGPT said. Okay, so good luck, humans. The next few years will be very, very interesting. So as the spring 2026 draws to close, I'm reminded of Tang Dynasty poem by Wang Bo, written as he was bidding farewell to a friend. Hai nen zu ji ji, tian ya ruo bi lin. With two friends across the world, even the end of the earth feel like close neighbors. Many of us came to Shanghai from faraway places to meet, discuss, and learn about the latest development across string theory. Thanks to the warmth and hospitality of our host, Strings 2026 has felt more like, not like being away from home, but like being part of one shared community. So even the end of us feels like close neighbor. So on behalf of all of us, I would like to say, 衷心感谢大家 und auf Wiedersehen in Hamburg. Thank you very much.